Hello friends, I'm Lakajit Oza here, and today we are going to start a new topic of uh, you know wave and optics, that is linearity and superposition principle. So before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. If you want to follow me on Insta, this is my Insta ID, Oza Lakajit, OZHA Lakajit, LAKHYAJIT 123. This is my Insta ID. You can follow me on Insta, and I have already made two lectures on this of this paper, wave and optics. Link of the two lectures are given in the description box. If you want to watch them, then you can watch them. Okay, so now let's start. So we know that differential equation of simple harmonic motion, differential equation of simple harmonic motion is given by second order derivative of y means displacement with respect to time t, plus omega square y is equal to 0. We have got this. Okay, so I have already explained how to obtain the differential equation of simple harmonic motion in the last lecture, so link is in the description box. Okay, now you say here in this case, this is a linear equation. This equation you see, this equation is a linear equation. Why it is linear? Because it doesn't contain, it doesn't contain terms containing higher orders of y's. So y square, y cube, y to the power 4 dot etc. Okay, so here the maximum power on y is 1. Okay, right? So that's why it is linear, right? Now you see, suppose this is the here you see this equation is a differential equation of simple harmonic motion. So at different instant t1 and t2, two different instants, so there will be two different displacements, right? So if these two are the solution of these equations, then their sum, if their sum is also a solution of this equation, then this equation is said to be linear and homogeneous equation. Okay, linear homogeneous equation, right? Now you see, let me just clean it. Okay, so if you say the sum of any two solutions, if the sum of any two solutions right, is also a solution itself, then here I have to mention this: if the sum of any two solutions of the equation, sorry, let me write here. This is suppose 1 of equation number 1 is it also a solution itself. Okay, then equation 1 is linear homogeneous equation. homogeneous equation, right? So hope you have understood this. Now let us discuss about superposition principle, right? So let me take a new slide. Now you see, let us consider a differential equation suppose second order derivative of y with respect to t is equal to minus omega square y plus a y square plus b y cube plus c y to the power 4 plus dot 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 and so on, etc. Okay, this is suppose equation number, let me take this is equation number 2, right? Now you see here, if a, b, c these constants are equal to 0, that means if we get only this part, then this equation will be linear and homogeneous. Okay, linear and homogeneous, and this equation to be linear and homogeneous, this constants must be 0. Now one more thing, so we are going to show that to satisfy the superposition principle, so it must be a linear and homogeneous equation. Now you see, if we consider that at an instant t1, y1 is the displacement, that's gonna be the solution of this, right? And at an instant t2, displacement is y2, suppose, that also be a solution of this. Then if these two is superimposed, then the resultant displacement y must be y1 plus y2, right? Okay, then this must be also a solution of this equation, right? And to satisfy this condition, it must be linear homogeneous. Okay, so we are to show that. Now you see, just wait, let me, okay, now you see, suppose y1 and y2 are two solutions of equation number 2 at instance t1 and t2 respectively, right? Then what we can write for this solution, this equation number 2 can be written as second order derivative of y with respect to time t, sorry, y1, not only y, y1, just wait, let me copy this equation, so then it will be easier to write. So y1, here y1, y1 and y1, this is the equation for y1. Similarly for y2, we gonna have this equation, y2, here y2, here y2, here y2, etc. So this is suppose equation number 3 and this is suppose equation number 4, right? Now you see, according to superposition principle, right, when the two instants superimposed on each other, the resultant displacement according to superposition principle it should be y is equal to y1 plus y2 is y is equal to y1 plus y2. So now let me copy these three equations and let me take a new slide. Okay, first let me copy equation number 2 and let me take a new slide. This is the equation number 2. Okay, and then let me take 3 and 4 as well. So now these are the two equations, 3 and 4. Okay, now you see, just give me a second, let me rearrange these things so I get enough space for further simplification. Right, now you see, according to superposition principle, right, as I have already mentioned, that resultant y should be y1 plus y2. So now we are to show that this will be also a solution of this equation if a, b, c, these constants are equal to 0, right? So by superposition principle we have already got that y is equal to y1 plus y2. Okay, so now for this y, the equation of resultant displacement, the equation of resultant displacement will be given by, or is, we can write, if we put here this you see, displacement, just wait, give me a second, let me write here y is equal to y1 plus y2 is from equation number 2, what we're gonna have here, y1 plus y2, right, divided by dt square minus omega square y1 plus y2, then plus a, instead of y we're gonna put y1 plus y2 whole square, and this is, instead of y cube we're gonna put y1 plus y2 whole cube plus c into y1 plus y2 to the power 4 plus dot 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 so on. That's what we're gonna have, right? So let me take this as equation number 5. Okay, now if we add equation number 3 and 4, let us add equation number 3 and 4. So adding equation number 3 and equation number 4, if we do so, then what we're gonna have, we're gonna have this one plus, then we're gonna have this d square y2 by dt square. That's what we're gonna have. Then on the other side, what we're gonna have, you see, if you add this one and this one, you can take this terms common, then you're gonna have minus omega square is equal to y1 plus y2. That's what you're gonna have, right? Then plus, and if you add these two terms, because we are adding these two equations, right, 3 and 4, so then you can take y common. Then if you take y common, sorry, not y common, a common, sorry, you can take a common. Then if you take a common, then what you can write, a is taken common, within bracket you're gonna have y square plus y1 square plus y2 square. That's what we're gonna have. Then from here you see we can take b common, then we're gonna get y1 cube y2 cube within bracket, right? Okay, just let me write this one here. So here we're gonna get b to the power b into y to the power 1 cube y to the power 2 cube when b is taken common, right? So we end up getting y1 cube plus y2 cube within bracket. Similarly, if you take c common, then you're gonna get c y1 to the power 4 plus y2 to the power 4 plus dot 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 so on, right? So this is suppose equation number 6. Now let me copy the equation number 5 and 6 and let me go to a new slide. Okay, just wait, give me a second. So let me copy these two equations. So first let me copy this equation number 5. So here is the equation number 5, right? And the equation number 6 is this. Just let me copy this equation number 6. So here is the equation number 6. Okay, now you see, if you compare these two, comparing equation number 5 and equation number 6, what we're gonna have, we're gonna get here it should be equal sign, sorry, I forgot the minus sign. Okay. So just wait, it should be equal to minus omega, right? That's what we should get. So now you see this part must be equal to this part if we compare 5 and 6, right? So that's why comparing 5 and 6, we have got second order derivative of y1 plus y2 with respect to t is equal to second order derivative of y1 with respect to t second order derivative of y2 with respect to t. That's what we're gonna have. So here you see this is okay. If you open the bracket, then obviously you're gonna get these two, right? So from this equation we have got this, which is correct, right? So this is equation number 7, suppose. Similarly, here you can see it is clearly these two are equal, same as it is, right? Minus omega squared y1 plus y2, and if you say this, that is also again omega, this one plus this two. Okay, these two equations are true, but if you compare 5 and 6, this must be equal to this one, right? Comparing these two equations, we have got a y1 plus y2 whole square should be equal to a y1 square plus y2 square. But here you see this is possible only when a will be equal to 0, right? Because you see y1 plus y2 whole square cannot be equal to y1 plus y2 whole square, sorry, y1 square plus y2, right? And to be both sides equal, this a must be equal to 0, right? Similarly, b y1 cube plus so b into y1 plus y2 whole cube, comparing these two, is equal to b y1 cube plus y2 cube, right? So on. That's how we're gonna get. So here you see, and these are supposed 9. This is equation number 10, right? So equation 7 and 8 are equal. Equation 7 and 8 are equal. Are true. Equation 7 and 8 are true, and but equation number 9 and 10 are true if A is equal to 0, B is equal to 0, and so C is equal to 0, etc. Right? Hope you have understood this. If A, B, C, these are 0. Now let me go to new slide. If A, B equal to C, these are all equal to 0, then you see equation number 2, this equation, here you see, this equation can be written, put A equal to 0, B equal to 0, C equal to 0, then this equation number 2 becomes, this one is equal to this only. So then let me go back to this. Then equation 2 becomes second order derivative of y with respect to t is equal to minus omega square y. Right? That's what we're gonna have. And this equation is linear and homogeneous. Okay. So from here, you see, to satisfy this condition, y is equal to y1 plus y2. Right? So this constants must be equal to 0. That means this equation is linear and homogeneous. Therefore you see, superposition principle is true if the equation is right, if the equation is it will be better if we write like this way: true in case of linear and homogeneous equation. Because this equation is linear and homogeneous. Right? Just wait. This is linear and homogeneous equation. So that's why we can conclude that superposition principle is true in case of linear and homogeneous equation. So hope you have understood. So in the next video we are going to discuss about superposition of two collinear harmonic oscillation. Right? Superposition of two collinear harmonic oscillation we're gonna discuss in the next video. So stay connected. Thank you for watching. See you in the next video. Bye bye.